Okay. Okay, so a little bit of review. Mean value theorem, right? Set two things equal to each other. What's the first thing? The first thing is the average rate of change. The average rate of change from beginning to end, right? That's the first thing. We find that. Once you find that, you find the derivative, and then you set them equal to each other and solve. And those are the points where the mean value theorem exists. Okay? That's what the mean value. Before we do that, though, we have to check to see if it's continuous and differentiable. So continuous continuity, just look for fractions, denominators, and roots. Those are really the issues where something's not going to exist. Differentiable means, does it have a derivative? If I were to find the derivative, would it exist? Okay, most things are going to be differentiable. That won't be an issue. Most of it will be, if there is an issue, it's dealing with continuity. Okay, so what I want you to do now is I want you to do example 4. I want you to do example number 4. Find those values that satisfy the mean value theorem. The intervals from 2 to 7, from positive 2 to positive 7. Okay, so first thing I did was find the average rate of change. So I needed to find the y values that went with 2 and 7. So I plugged in 2 to the original, plugged in 7 to the original. I got 2 comma 52. That's the first point. That's the starting point. 7 comma 47 is the ending point. Okay, so I use that to find my average rate of change. So over the course of from 2 to 7, the average rate of change was -1. Okay, first step. Second step, find the derivative of the original. So the derivative was 3x squared minus 16x plus 4. That's step 2. Step 3, set them equal to each other and solve. So I set them equal to each other, added 1 to both sides, set it equal to 0. It's a trinomial. So I factored it using trinomial steps. There was no GCF. So I just factored it like I normally would. And I got 3x minus 1 and x minus 5. Once I did that, set those factored terms equal to 0, and you get 2 answers. You get positive 1/3 and positive 5. One of them, like I told you guys, one of them won't work 1/3 because it's not inside the interval. It's too small. The interval starts at 2 and ends at 7, so that one doesn't work for our question. It's an answer, but it doesn't work for our question because it's not within the interval. And then 5 is the other answer. That one works. That one's in the interval. So when x is equal to 5, at that point, it'll have a derivative of -1. So if I was to find the derivative and plug in 5, if I was to find the derivative, I did, and plug in 5, I'd get -1 as an answer. They'd have the same derivative. That's what the mean value theorem says. Okay, that's the point at the graph where I was going the same speed as my average rate of change. Okay. All right. Okay, so last thing. Last thing. We're going to tackle this more next week, but I kind of wanted to give you guys a look at it. The last thing is graphs, looking at graphs. Because one of the biggest things, there's 3 things in this class that we look at the most, or we look at. One is equations like we did here, f of x, g of x, those things, right? Those are equations. The second thing is tables, how to read tables. We've done that a little bit. The last thing is graphs, how to read graphs and analyze graphs. Analyzing graphs is one of the bigger things we're going to do. Okay, so the graphs on number 5 match. So the left side. So the left side are all f of x's, originals. The right side are all are all derivatives. What we have to do is match the correct derivative with its original. Okay, we don't have equations. I don't have tables. I just have to do this using the graphs. Okay, so let's talk about what these are. First, this is the original, right? The original equation, that's over here. Looks like the first one's quadratic. Looks like the second one is sine. Looks like the third one is cubic. Okay. Derivatives. This is a graph of what? What is this a graph of? Heard someone. These are graphs of slopes. Yeah. Slopes of these guys. These are graphs of slope. What is the slope at a certain time? So the first thing I say when you're doing graphs, when you're analyzing graphs and you're looking at derivatives, is start with where are there horizontal tangent lines over here? So what I want you to do is go make dots on each of these graphs. Where are the horizontal tangent lines? Make dots. Horizontal tangent lines. So if I was to find the derivative, it would look like that. Where on these graphs would they be? So make dots on them. That's the first thing I do when I'm doing this. This is the first thing I do when I'm analyzing. They might have one dot. They might have two dots. They might have three dots. They might not have any dots if it's never horizontal. Okay. So for example, the first one. Number one, I'm starting on the left. Number one, how many dots is number one going to have? One dot at the minimum, right? How many dots is number two going to have? Two. One at the maximum and one at the minimum. How about number three? One kind of in the middle, right? It's not really horizontal there. It's kind of like this guy is increasing, and then it looks like it's slowing down increasing, but it looks like so might be one here. Okay. So let's start with how is that going to help these guys? Well, at this point here, and at this point here, and at this point here, what is the slope at those little tick marks? What is the slope here, here, and here? 0, right? Where is 0 on the graph? So if I want to find zeros on the graph, where is that going to be? So if I say find the zeros on a graph, where would that be? X-intercepts, right? So these guys should have x-intercepts. This guy should have an x-intercept here, here, and here. So go to the other graph. Which one crosses the x-axis 2 times? B, right? B crosses the axis 2 times. Where? Here and here. Why does it cross the x-axis? Because it had a slope of 0. It had a slope of 0. So horizontal tangent lines equate to zeros on the derivative graph, right? Another way to do it. So now that we know 2 goes with B, before the first blue dot, what is this guy doing? Increasing or decreasing? Increasing, right? Is that a positive derivative or a negative derivative? So shouldn't this guy have a positive slope before that? This is positive, right? It's positive because it's above the x-axis. Positive means above the x-axis. Then what happens after this blue dot? Decreasing, right? Decreasing. Decreasing means positive or negative slope. So that means below the x-axis. And then after this blue dot, it starts increasing again. Positive slope above the x-axis. Okay? That's another way of looking at it. A third way of looking at it. Didn't we just say that this looks like sine graph? What is the derivative of sine? Doesn't this look like cosine? That's another way of doing it. Okay? So if you're familiar with your graphs, what a quadratic looks like, what linear looks like, what cubic looks like, then it's kind of easier to find. Okay, so we got those two. So we know that, let me get, these two go together. Okay, so we have two left. So let's go to this guy right here. Let's go to this guy right here, number 1. We said that number 1 had one tangent line, right? Or one horizontal spot where it was a horizontal tangent line. So that means how many times should it cross the x-axis? How many times should its derivative cross the x-axis? Once. Which one crosses just once? C, yeah. C does right here, right? And isn't it in the same spot? The same x value? Right? And when I find the derivative of a quadratic, when you find derivatives, aren't you taking away powers? So it goes down, right? So a quadratic is squared. So if I take away squared and go down, that's linear. That's another reason why. Okay, so this guy and this guy. So this guy here, number 3. We said that maybe it's kind of horizontal-ish here, right? But not quite, right? That reflects in there. It doesn't cross the x-axis, it touches it. It touches it, okay? Because the slope before was positive, and then the slope afterward is positive. That's why it kind of makes that guy there. And that's the last one. This is one of the more difficult things to do, not because it's hard, but because you don't have an equation to fall back on. You guys so used to, okay, find the derivative. You guys can do that. We just took a test on it. But it's so hard when you have a graph. And I'm going to tell you right now, your next test, you're going to have FRQs that are going to just be graphs, and you have to analyze the graph. Okay? I'm going to give you derivatives, and I'm going to say, where was the original increasing? Where was the original increasing? Well, if this is a graph of slopes, it should be positive, right? So that's increasing because it's positive, reflects a positive number, and this is increasing, right? It's kind of backwards because you're thinking, this is not increasing, but you're not thinking about this graph, you're thinking about the original graph. And above the x-axis means a positive slope, below the x-axis means a negative slope. Okay? So analyzing graphs is one of the, like I said, it's one of the more difficult things we do because you don't have an equation to fall back on. You have to understand, you have to truly understand what a positive slope is. What does increasing mean? It means positive slope. What does decreasing mean? It means negative slope. Things like that. Okay, we'll do more practice. So that's one of the things we're going to do next week. Next week, we're going to do two things. One goes with what we did earlier this week, and the other one is reading graphs, because reading graphs, like I said, it takes some time to get used to. Okay, so that's all I have. So the rest of the time, I want you guys to work on practice 16, or if you haven't finished practice 15, finish that. Okay.